All right, so I think this is recording. Let's take a look here at problem number 1. We have two rational expressions. They want us to multiply these together to get a single rational expression, to simplify it, write it in lowest terms, and to state any restrictions that we have. Restrictions in arithmetic come from we can't divide by 0. We also can't take the square root of negative numbers within the set of real numbers. But since we don't have any radicals here, any square roots, we don't have to worry about that. But we do have variables in a denominator, so we have to make sure that that denominator will never equal 0. All right, but let's start out by writing these two fractions as a single fraction. Um, in the numerator, we have x plus 7 times this trinomial, x squared minus 3x minus 40. And in the denominator, we have this binomial, 7x plus 35, times this binomial, x minus 8. Well, we don't see anything that cancels here. Now, our denominator, let's continue. Let's go ahead and factor this trinomial. So we'll go off to this side and do the x method. And we'll also factor this 7x plus 35. Both of these are divisible by 7. So let's come over to the side. And this x squared minus 3x minus 40. If we can rewrite that in factored form, then we might be able to see that there are some common factors in the denominator that might cancel. So to factor this, let's put an x over to the side. Let's put our middle term, negative 3x, at the bottom of the x. Take the first times the last to get the top of the x. And now, with trial and error, we look for two values that when multiplied together give us the top expression, but when added together give us the bottom. And I believe that that will be a negative 8x and a positive 5x, because the negative times a positive will get me the negative, and negative 8 plus a positive 5 gets me the negative 3. So there we found it. Now, with a leading coefficient of 1, we don't have to make a table down below here. We can just do a shortcut and just use the negative 8 and positive 5 and factor this to x minus 8 times x plus 5. Now let's also take a look at this 7x plus 35. 7x plus 35, if you rewrite 35 as 7 times 5, you notice that you have a common factor of 7 in both terms. Well, you can factor out that common factor, and what you have left will still be a binomial, but now in that first term you'll just have x, and in the second term you'll just have 5. So let's come back over here, and in our numerator we've got x plus 7, and this trinomial we said factored to x minus 8 and x plus 5. In our denominator, this first binomial here, we said it factored to 7 times x plus 5 and times x minus 8. Well, now a lot of things we can see is going to happen. We see factors now that are common, but before we start canceling common factors, let's state our restrictions now when we can see what they are, because later when these factors cancel out, we won't see it anymore to be able to know what restrictions we have. So a negative 5 plus a positive 5 would give me 0, and 0 times anything is going to give me 0. I need to prevent x from ever equaling negative 5. For this other factor, positive 8 minus 8, well, 8 minus 8 gives me a 0, so I need to also make sure that x will never equal 8. And now I'm in business, because now I can come over and say, well, I've got this factor of x minus 8 divided by that x minus 8, and that's 1, so we just say that cancels. And the x plus 5 divided by x plus 5, that's also 1. So what are we left with? In the numerator, we're left with just this x plus 7. And in the denominator, we're left with 7 here. Now, we cannot come in and cancel this term with this factor of 7. The only thing that you could do would be to take x and divide it by 7, and to take 7 and divide it by 7, and then you could cancel the 7's, and this would be x over 7 plus 1. But we don't need to do that. I'm just going to leave my answer as x plus 7 over 7. But definitely do not cancel this term with that factor. Only if that addition was multiplication would you be able to do it. So our restrictions were that x can't be negative 5 or positive 8. All right, so there's our final answer. Well, I hope that helps, and I'll talk to you later. Bye.